Hi everyone, this is Aman Kumar. Welcomes all of you at Brilliant Academy. In today's lecture, we are going to learn our next chapter, that is area related to circle. We already know about how to find the area of a circle and how to find the circumference of circle. And in this chapter, we learned about how to find the area of a sector and how to find the area of a segment. Okay, so let's start our today's lecture. Well, we know about area of circle is pi r square and circumference of circle is 2 pi r. Now we see how we find the area of a sector. So first we see what is a sector. So look here, this is my circle with center O, and I cut a small part of circumference of this circle. Suppose I cut this part from this circle, okay, then this part will become like that. This is AB. Now what is sector? This one is arc. Okay, this is an arc. If I cut a smaller part of this circumference, then this will become arc. This smaller one is minor arc, and this bigger one, this one. This smaller is minor arc, and this bigger one is major arc. So I draw it. This is major arc, and this one is minor arc. Now look how sector becomes. Now this is a part of this circle. If I meet this A and B point to center like that, if I join AB and AO and AB, then this part is called sector. Okay, and the smaller one is called minor sector, and this bigger one is called major sector. Okay. Now, in this chapter, we have to find the area of this minor sector and major sector. Look how we find. This part makes an angle with center. Okay. Suppose I take this angle as theta. Understood? This part, this sector makes an angle with center, and this angle we named as theta. So now look here. Area of circle is pi r square. If I draw another sector like that, okay, CD arc, again I draw DE arc, then again this angle is theta 2, this is theta 1, then this is theta 3, this one is theta 4. Now if I add these four angles, all angles 1, 2, 3, 4, theta 1, 2, 3, 4, then theta 1 plus theta 2 plus theta 3 plus theta 4, all angle is equals to 360 degree. Why? Because a complete circle have a 360 degree angle. So now look here, if I add theta 1, 2, 3, 4, all the sectors, then this all sector will become one circle, and the area of one circle is pi r square. Okay, so area of one complete circle is pi r square, and this pi r square is for 360 degree. Theta 1, 2, 3, 4 is 360 degree. So area of this will become area of complete circle. Now the complete angle is theta 1, 2, 3, 4 is 360 degree. So pi r square is for 360 degree. Okay, for 360 degree, pi r square is area. Now for 1 degree, area is pi r square upon 360 degree. Okay, so now this sector make an angle of theta with center. So for theta degree is what? Theta upon 360 into pi r square. This is the area of a sector, and this area is for minor sector, not major. This is for minor sector. Okay, this is the area of minor sector. Area of minor sector. Okay, so now look how we find the area of major sector. This is the area of minor sector. Then area of major sector is what? Area of circle minus area of minor sector. Okay, so look here, this is my circle, this is my minor sector. Now I have to find the area of this one. So what I do, I subtract the area of this sector, minor sector, from this whole circle, then I get the area of this part. So area of major sector is what? Area of circle minus area of minor sector, and area of circle is pi r square minus area of minor sector is theta upon 360 degree into pi r square. So theta upon 360 degree into pi r square. Now pi r square is common from here, so we left 1 minus theta upon 360 degree. This is the formula for area of major sector. This is the formula of area of minor sector. Okay, let's see one more time how we find the area of sector. We know area of circle is pi r square. Okay, now this AB is an arc. So from arc, if I join this A to the center and this point B to center, then I get one part of circle, this part, and this part is called sector, and the smaller one is called minor sector, and the bigger one is called major sector. Now this AB makes an angle with center, and I name this angle as theta. Okay, so first I see area of whole circle is pi r square, and in a circle there is 360 degree angle, so I write it here. Pi r square is for 360 degree. So for 1 degree is what? For 360 degree area is pi r square. So for 1 degree area is pi r square upon 360 degree. Okay, so now look here, this angle is theta. So for 1 degree is this one. So for theta degree is theta upon 360 degree into pi r square, and this is the area of minor sector. Okay, now what is the area of major sector? If I subtract the area of this minor sector from the whole circle, then I get the area of this part, then I get the area of this part, and this part is major sector. So I write it here, area of circle minus area of minor sector. Area of circle is pi r square, and area of minor sector is theta upon 360 degree into pi r square. So now I take pi r square as common, then I left 1 minus theta upon 360 degree. This is the area of my major sector. Understood? Now next thing we learn is how to find the length of an arc. So look here, this is my circle with center O, and now this one is my arc. This AB is an arc. Now is this smaller one is called minor arc, and this bigger one is called major arc. Okay, so look how we find the length. Length means distance between A and B. Now the length of whole boundary of the circle is what? The length of whole boundary of the circle is equal to circumference, which is 2 pi r. Length of whole boundary of circle is 2 pi r, and this 2 pi r is for 360 degree. Whole angle in a circle is 360 degree. So 2 pi r is for 360 degree, just like a sector. So for 360 degree, the length is 2 pi r. Now, so for 1 degree is what? 2 pi r upon 360 degree. Okay. Now this arc make an angle with center, and I name this angle as theta degree. Okay. So now look, for 360 degree, this is 2 pi r. For 1 degree, 2 pi r upon 360 degree. The same for theta degree, length is what? Theta upon 360 into 2 pi r. This is the length of arc, and this is for minor arc. So this is for minor arc. Now for major arc is what? We subtract this length of minor arc from circumference of a circle, then we get the length of this part. Okay, major arc. So I write it here, length of major arc is circumference minus length of minor arc, and circumference is 2 pi r minus length of minor arc is theta upon 360 degree into 2 pi r. This is theta upon 360 degree into 2 pi r. So from here 2 pi r is common, then what we left? 1 minus theta upon 360 degree. This is the length of major arc. Okay, let's see one more time. We have to find the length of an arc. So look, this is my circle with center O. This AB is an arc, a smaller one is minor arc, and the bigger one is major arc. Now we know that the circumference of circle is 2 pi r. The length of the whole boundary of a circle is 2 pi r, and this 2 pi r is for 360 degree. So I write it here, for 360 degree length is 2 pi r. So for 1 degree length is 2 pi r upon 360 degree. Now this arc make an angle of theta with center. So for theta degree, angle is what? Theta upon 360 into 2 pi r, and this is the length of minor arc. Now how I find the length of major arc? I subtract the length of minor arc from circumference of a circle. from this one is length of minor arc and this is the length of whole circle. So I subtract this length from the bigger one, then I get the length of this circle, that is major arc. So circumference minus length of minor arc, 2 pi r is circumference and this one is the length of minor arc. So I get 2 pi r is common. So 2 pi r in bracket 1 minus theta upon 360 degree. This is the length of major arc and this is the length of minor arc. Okay, got it? Now let's see some examples related to area of a sector and length of a arc. So look, this is our first example. Question is what? Find the area of a sector of circle with radius is 6 centimeter. This is 6 centimeter and angle of the sector is given, that is 60 degree. We have to find the area of the sector. Okay. So question said that there is a circle with an arc and now this makes an angle of what? 60 degree with center and radius of this circle is given 6 centimeter. Okay, so radius is given, this one is 6 centimeter. So we have to find the area of this sector. Okay, so look here, first what is given? Radius is given, which is 6 centimeter and angle, which is theta, is also given, that is 60 degree. Now we have to find the area of sector. So area of sector is what? If question given that find the area of sector, then we have to find the area of minor sector. If question said find the area of major sector, then we have to find the area of major sector. Otherwise, we only have to find the area of minor sector. If nothing is given, then we have to find the area of minor sector. So area of minor sector is what? Theta upon 360 degree into pi r square. Now theta is what? 60 degree. This is given upon 360 into pi is what? 22 by 7 and r square is 6 centimeter. So 6 into 6. Okay, now 0 cancel, 6 6 are 36 and this 6 cancel this 6. So what we have? 22 by 7 into 6. So we have 22 by 7 into 6. Now we multiply this. So 6 2 is 12, 6 12 or 1 13 upon 7. This is the area of this sector. Okay, which is 132 upon 7 centimeter square. Understood? Let's see one more time. Question said there is a circle with radius 6 centimeter and there is an arc which makes an angle of theta. Then we have to find the area of this sector. So I write radius is given 6, angle is given 60 degree. Formula of sector, area of sector is theta upon 360 degree into pi r square. So theta is 60 upon 360, 22 by 7 is 5 and 6 into 6. Now after calculation, I get area of sector is 132 upon 7 centimeter square. Understood? Now the next thing that we have to learn in this chapter is how to find the area of a segment of a circle. So first see what is the now the next thing that we have to learn in this chapter is how to find the area of a segment of circle. Okay, so first we see what is the segment of a circle. So look, suppose this is my circle with center O and I draw a chord. You all know what is chord? Chord is the line which intersect the circle at 2 points. Now this is the chord AB, then this area is the segment. This area is called segment and this is a smaller one, so this is called minor segment. Okay, and now this one is bigger one, so we say this is as major segment. Understood? What is segment? Segment is the area bounded by the chord. In definition, I write segment is area bounded by the chord. This is the chord AB, and this area is called segment, and the smaller one is minor segment, and the bigger one is major segment. Now we learned how to find the area of this segment. Okay, so look here how we find. Now this is my center O. Okay, for this area, first I join OA, then I join OB. Now look, this is my triangle, this make a triangle and this is the arc. This AB is an arc, so this AB is an arc. I draw a separate figure. This is chord AB, okay, and this is an arc. If I erase this chord, then this will become an arc. Okay, now when I join A and B with center then this will make a sector. Okay, so now if I subtract the area of this triangle from this sector, then I got the area of this segment. Okay, look here, this is a triangle. Now I subtract the area of this triangle from this sector, then I get the area of this part, and this part is called segment. So area of segment is what? Area of sector minus area of triangle. Okay, which sector? This one is minor. If I don't write any minor or major, then we are talking about minor segment. If I write major, then we are talking about major segment. If nothing is written, then we are talking about minor segment. So look here, so area of minor segment is area of minor arc minus area of triangle. So this is the area of minor segment. Now how we find the area of major segment? So area of major segment is what? This one is the area of bigger circle, and if I subtract the area of minor segment from area of circle, then I get the area of major segment. This is my circle, this is area of minor segment. If I subtract this area of minor segment from this whole circle area, then I get the area of this part, that is major segment. So area of major segment is area of circle minus area of minor segment. Understood? Area of minor segment is what? Area of sector minus area of triangle. Which sector? This is the area of sector in which I subtract the area of this triangle. So this is the area of minor segment. Now area of major segment is what? Area of circle minus area of minor segment. Okay, so this is whole area of whole circle. If I subtract the area of this part from the area of whole circle, then I get the area of this major segment. Okay, now let's see one example of how to find the area of a segment. The question is what? Find the area of a segment of a circle of radius 7 cm and angle of the sector is 90 degree. Question said that we have to find the area of segment of a circle in which the radius is given 7 and area of sector is given, angle of sector is given 90 degree. Suppose this is my circle. Okay, now sector angle is 90 degrees given. So look, this is an arc AB. Now where I join this arc AB to the center, then I get this is sector and this angle is given which is 90 degree. Now we have to find the area of segment. So this is my chord AB. Okay, this is a chord AB. Now we have to find the area of this part, this segment. If nothing is written, then we have to find the area of minor segment. So we have to find the area of this. Now this is center O. So for this segment, what I do, I subtract area of this triangle from the area of sector. Okay, this is the radius is given, that is 7 cm. Now look, so radius is given 7 and theta is given 90 degree. Now area of segment is what? Area of segment is area of sector minus area of this triangle. So this is area of sector minus area of triangle. Which triangle? AOB. Okay, AOB. Now area of sector is what? Theta upon 360 degree into pi r square, and area of triangle is half into base into height. Now theta is given which is 90 degree, so I put it here 90 upon 360 degree. Now pi is what? 22 by 7 and r square is 7 into 7, that is 7 into 7. Now this is half into base into height, half. Now what is base and what is height? Look, this triangle AOB. Now this angle is 90 degree given, so this angle AOB is 90 degree given, which means this triangle is a right angle triangle. Now the side which is opposite to the 90 degree is called hypotenuse. So for this triangle AB is hypotenuse. Okay, this is triangle AOB and this angle is 90 degree. So what is hypotenuse? Side which is opposite to 90 degree. So this is hypotenuse, then this is perpendicular, then this is base. Now OA is radius, OB is also radius. So perpendicular is 7 cm and base is also 7 cm. So B into H is 7 into 7. Now calculate this one. This will cancel out by 4 times. 90 into 4 is 360 degree. Now this is 2 to the 4 and this is 11 to the 22. And this 7 cancels this 7. So now what I left here, from here I left 11 into 7 upon 2. This is 11 into 7 upon 2. Now from here what I left, 7 into 7 upon 2. Okay, now from these two I take 1 by 2 as common, not 7 by 2 is a common, so I take 7 by 2 as common. Then from here what I left, only 11. Now minus, from here what I left, 7. So this is 7, so this will become 7 upon 2 multiplied with 11 minus 7 is 4. So 4 is cancelled by 2 times, so 7 into 2 is, so here area of segment is what, 14 centimeter square. Okay, this 7 multiplied by 2 is 14 centimeter square. Okay, let's see one more time. Question said that there is a circle with center O and radius is 7 centimeter, and this circle have an arc, and this arc makes an angle of 90 degree with center. Then we have to find the area of this segment. So I write area of segment is area of sector minus area of triangle. This triangle AOB. Okay, so area of sector is this one formula, and area of triangle is half into base into height is the formula. So theta upon 360 degree, which means 90 upon 360, 22 by 7, and R is 7. So I add 7 into 7. Now half into base into height. Half is half. Now how I consider base and height? This AOB is a right angle triangle. Okay, now this AB is hypotenuse. Why? Because side which is opposite to 90 degree is the hypotenuse. Then this is perpendicular and this is base. So AOB is perpendicular and OB is base. So now AO is again radius and OB is also a radius. So 7 and 7 both are 7. So half into base is 7. Height is also 7. Okay. So now after calculation, I get here 11 into 7 upon 2. Now just 7 into 7 upon 2. So I take 7 by 2 as common. Then I left 11 minus 7. Now 7 upon 2 into 4. It cancels 4 by 2 times. Then 7 into 2 is 14 centimeter square. This is the area of segment. Okay. Now let's practice some questions related to this area of sector and segment. So first question is, find the area of a quadrant of circle of circumference 22 centimeter. Question said that there is a circle in which the circumference is given, which is 22 centimeter, and we have to find the area of a quadrant of a circle. Quadrant means 1 by 4th part of a circle. Okay, so look here, this is my circle and circumference is given 22 centimeter. Quadrant means 1 by 4th part, so we have to divide this circle into 4 parts. So look, this is diameter, suppose this is diameter, so this one is first part, second part. Again I draw one diameter in this way. Then this one is first part, second part, third part, and this one is fourth part. So we have to find the area of any one part of from 1 to 3 4. From 1 2 3 4 I have to find the area of any one part of this circle. Whose circumference is 22 centimeter. Now suppose I take this part, then this is AB diameter, CD diameter, this is center O. So I take this part, then this one is sector, then this BD is an arc, and this makes an sector. So we have to find the area of this part, which is area of this sector. So for this sector, what I need? First I need this angle. Okay, so I draw this diameter like that. They both are perpendicular to each other, which means this angle is 90 degree. So this one is also 90, this one is also 90, and this one is also 90. So I take this part. So here theta is my 90 degree. So from here theta is 90 degree. Now one more thing is left, which is radius. So how I find radius? The circumference is given. So by using circumference, I find radius. So first I write what is given. Circumference is given. Is equal to what? 22 centimeter. Okay. Now formula of circumference is 2 pi r is equal to 22 centimeter. Okay. So from here 2 into 22 by 7 into r is equals to 22. So now r is what? 22 multiplied with 7 upon 2 into 22. Now this 22 is cancelled, so r I get is 7 upon 2 centimeter. Okay, this is my r, which is radius, that is 7 upon 2 centimeter. Now I have to find the area of quadrant. So this will make a sector. So area of sector is this is a sector, which is theta upon 360 degree into pi r square. So now look here, theta is what? Theta is 90 degree upon 360. I solve it just below. Theta is 90 upon 360 degree into pi is 22 upon 7 into r square, that is 7 upon 2 into 7 upon 2. Now 90 4s are 360, so 360 cancel by 90 4 times. Now this one is cancelled, 11 to 22, and now this is 2. Okay, this 7 and this 7 is cancelled out. So here what I left, 11 into 7, 11 into 7 upon, now in denominator 2 into 2 into 2, 2 multiplied with 2 multiplied with 2. Now 11 into 7 is 77 upon 2 into 2 is 8. So that is the area of quadrant, which is 77 upon 8 centimeter square. Understood? Let's see one more time. Question said there is a circle in which circumference is given, that is 22 centimeter. We have to find the area of quadrant of this circle. Quadrant means 1 by 4th part. So first we have to divide this circle into 4 parts. So I divide this circle into 4 parts by drawing or constructing two diameters which is perpendicular to each other. So first diameter is AB and second diameter is CD. First I draw vertical diameter AB and there is horizontal way CD, and these both are perpendicular to each other. Now this is first part, second part, third part and fourth part. So we have to find the any one quadrant. Okay, so I take this quadrant. So for area I have an angle, so there is angle theta is 90 degree. Now another thing is required, which is radius. So I find radius using circumference. So circumference is 22 centimeter. So 2 pi r is equal to 22. Now from this I get r, which is 7 upon 2 centimeter. Now area of quadrant. This quadrant is make sector. So area of sector is theta upon 360 degree into pi r square. Now I put the value, then I get area of quadrant is 77 upon 8 centimeter square. Understood? Let's see our next question. Question is what? Length of a minute hand of a clock is given, that is 14 centimeter. Find the area swept by the minute hand in 5 minutes. Look here, there is a clock. Okay, this is a clock, and the length of a minute hand of this clock is given, which is 14 centimeter. Understood? This is given 14 centimeter. Okay. So we have to find the area when this minute hand covers 5 minutes. Okay, when this minute hand covers 5 minutes. So now look, when minute hand is here, the position of this minute hand when it covers 5 minutes will, suppose this initial position is this at 12, when 5 minutes complete, then position of this minute hand is pointing towards 1. So now, okay, so we have to find this area. Now look here, if I draw imaginary line, if I draw a path of this rotation of minute hand, then I get a circular path. When I draw the path of the rotation of this minute hand, then I get one circular path. Okay, so there is a circle. Now this is a circle with radius 14 centimeter, because the length of minute hand is given, which is 14 centimeters. So this is a circle with radius 14 centimeter. Okay, now we have to find the area of this region. Now look here, this is center, and this will make an arc, and this will make a sector. So we have to find the area of the sector in which radius is given 14 centimeter, but we don't given an angle. First we have to find the angle. So look how I find angle. When this minute hand rotates completely, then it's covered total 360 degree angle. Why? Because in circle there is a complete revolution, which is 360 degree. So when this minute hand rotates, then it covers a total 360 degree angle. So angle in complete revolution. Complete revolution means total 60 minutes, 5, 10, 15, 20, 25, 30, whole becomes 60 minutes. So angle in 60 minute is what? Total 360 degree. Okay, so angle in 1 minute is what? 360 degree upon 60. So angle in 5 minutes is what? 360 upon 60 into 5. Now this is cancelled by 6 times, so this is 30 degree. So angle in 5 minutes, when the minute hand covers 5 minutes, then it makes an angle of 30 degree. So now I have theta, which is 30 degree, and radius, which is 40 centimeter. Now I have to find the area of this part, which is sector. So area of sector is what? Area of sector is what? Theta upon 360 degree into pi r square. Now theta is 30 degree upon 360 into pi, which is 22 upon 7. Now r square, which is radius. So radius is given, which is 14 into 14. Okay, now this is cancelled by 12 times 7 2 are 14, 2 6 are 12. Okay, now this is 7 2 are 14, 3 2 are 6. So what I left here at numerator 22 and 7. So at numerator 22 into 7. Now at denominator I left only 3. So after calculation 7 to the is 14, 7 to the 14 is 15, 154 upon 3 centimeter square. So this is the area of minute hand when it swept by 5 minutes. Understood? Let's see one more time. Question said that there is a clock in which the length of minute hand is given 14 centimeters. Then we have to calculate the area when this minute hand swept 5 minutes. Okay. So see, this is my clock. I draw an initial position of minute hand at pointing 12. Now, when this minute hand covers 5 minutes, then this minute hand pointing towards 1. Okay. Then this is the final position of minute hand. Now we have to find the area of this region. So first I draw the imaginary path of this minute hand. When it travels complete one revolution, then this is the imaginary path of this minute hand. And now look, this imaginary path is in the form of circle. So we have to find the area of a sector of a circle in which radius is given 14 centimeter and angle is not given. We have to first find the angle. So look how I find the angle. When minute hand completes one revolution, then it's covered total 60 minutes and in 360 degree. So angle is 360 degree for 60 minutes. So for 1 minute angle is 360 upon 60. So for 5 minutes, what is the angle? 360 upon 60 into 5. So this is 30 degree. Now I have a theta which is 30 degree, radius which is 40 centimeter, and the path is circular path. So we have to find the area of a sector. So area of sector is theta upon 360 degree into pi r square. Now theta is 30, I put the values, then I get the result which is 154 upon 3 centimeter square. This is the area of sector or area of the minute hand when it swept by 5 minutes. That is 154 upon 3 centimeter square. Okay. Now let's move towards our next question. The question is what? In a circle of radius 21 centimeter, an arc separates an angle of 60 degree at center. Then we have to find length of arc, area of sector, and area of segment formed by corresponding chord. So look here, question said that there is a circle. In this circle, an arc separates an angle of 60 degree at center. So suppose this is my arc AB. Okay. Now this arc AB subtends a 60 degree angle at center. Okay. This is my center O. Now this arc AB subtends a angle of 60 degree at center. Then first I have to find the area of this sector, then find the length of this arc AB, then find the area of segment formed by corresponding chord. Corresponding chord means this chord. Okay, this one. So I have to find the area of this segment. So first let's see how we find the length of an arc. So first I get what is given. So radius is given which is 21 centimeter and theta is given which is 60 degree. So first length of arc. Formula is what? Theta upon 360 degree into 2 pi r. So theta is 60 upon 360 degree into 2 into 22 upon 7 into r is given 21 centimeter. Okay. So now this is cancelled by 6 times. 7 3s are 21, 3 2s are 6 and 2 is 2 cancelled. So length is 22 centimeter. This is the length of arc. Length of arc which is 22 centimeter. Now second thing is find area of sector. So we know the formula. What is the area of sector? Area of sector is equal to what? Theta upon 360 degree into pi r square. So from here theta is 60 upon 360 degree into pi is 22 upon 7 into r square, which is 21 into 21. Now 6 6 is 36, 7 3 are 21, 3 2 are 6, and 2 into 11 22. So now what I left, 11 into 21. Okay, 11 into 21. Now we multiply it 21 and 11. So this is 21, this is 21. 1 3 2. So 231. So area of sector is 231 centimeter square. Next thing we have to find is area of this segment. So area of this segment is what? Area of this sector minus area of this triangle. So first we have to find the area of this triangle. So now look here, this triangle is an equilateral triangle by one angle is 60 degrees. So another two is also a 60 and 60 degrees. Look how 60 and 60 degrees. OA is radius, OB is radius. Okay, OA is radius and OB is radius, which means this and this are equal. So this angle and this angle are also equal. So these two are equal and this is 60 degree. So these two are also a 60 degree. Why? If I do angles of property, then 60 plus angle A plus angle B is 180 degree. So now 60 plus A and B are equal. So I add 2 of angle A equals to 180 degree. So 2 of angle A is what? 180 minus 60. So angle A is what? 120 upon 60. Sorry, 120 upon 2. So then from here I get angle A is 60 degree. So this is 60. Then angle B is also 60. Why? Because they are equal. Because OA and OB are radius. Understood? So now look at this triangle AOB is an equilateral triangle. So area of equilateral triangle is root 3 by 4 A square. So first I write find area of this triangle. Okay. Area of triangle AOB is what? Root 3 upon 4 A square. So now I calculate this. Root 3 upon 4 A square is square and side is 21 centimeter. So 21 into 21. So now look here. A square of 21 is 21 into 21. 441. So 441 root 3 upon 4 centimeter square. Area of this triangle is this one. Now we have to find the area of this segment. So area of this segment is area of sector minus area of this triangle. Okay. So I find it here. I find it third one here. Area of segment is what? Area of this sector minus area of this triangle AOB. So area of segment is area of sector minus area of triangle AOB, which is area of sector is 231 minus area of triangle AOB is 441 root 3 upon 4. So this is the area of this segment, which is 231 minus 441 upon 4 root 3 centimeter square. Understood? Let's see one more time. Question said that there is a circle in which radius is given 21 centimeter and angle separated by this arc at center is also given 60 degree. So we have to find the area of area of sector, length of arc, then area of segment formed by corresponding chord. Corresponding chord means this chord. Okay. So look here. First I write what is given, radius and theta is given. So I write it. Now length of arc is theta upon 360 degree into 2 pi r. Now I put the value, then I get result which is 22 centimeter. Now this is the length of an arc. Second thing is find area of sector. So formula is theta upon 360 degree into pi r square. Again I put the values, then I get result which is 231 centimeter square. Now third thing, we have to find the area of segment. So for area of segment, first we have to find the area of this triangle. Now look, this triangle is an equilateral triangle. How? This is 60 degree. Now OA and OB are equal because they both are radius. So this angle and this angle are also equal. So this is 60 and this is 60. So now all angles are 60 degrees. So this AOB triangle is an equilateral triangle. So area of equilateral triangle is root 3 by 4 A square. I put the values, then I get area is 441 root 3 upon 4 centimeter square. Now I have the area of triangle. So area of segment is area of sector minus area of triangle. Which triangle? AOB. Now area of sector is 231. So I write 231. Now area of triangle is 441 root 3 upon 4. So I write 441 root 3 upon 4. Now this is the area of segment. Okay. Let's move towards our next question. So question is what? A chord of a circle of radius 12 centimeter subtends an angle of 120 degree at the center. Then we have to find the area of the corresponding segment. Okay, so look here, there is a circle in which AB is an arc, and this arc subtends an angle of 120 degree at the center. Okay, and AB is the chord. This AB chord subtends a 120 degree angle at center. Okay, either AB arc or AB chord. Now the radius of this circle is given, which is 12 centimeter. Then we have to find the area of corresponding segment, which means we have to find the area of this part. Okay, this segment. So for area of this segment, first we have to find the area of sector, which is formed by the arc AB. Then we have to find the area of triangle AOB. Then I subtract the area of triangle AOB from this sector. Then I get the area of segment. So first we write what is given. So radius is given 12 centimeter and theta is given 120 degree. So first thing we have to find area of sector. Now area of sector is what? Theta upon 360 degree into pi r square. So now look here, theta is 120 degree upon 360 into, we have to take pi as 3.14 into r square, which means 12 into 12. So this is 12 into 12. Now 0 0 cancel and 12 3 is 36. Okay. Now 3 4 are 12. So we have 3.14 into 12 into 4. So this is 3.14 into 12 4 are 48. Now we multiply 3.14 into 48. Then we get 150 upon 0.72 centimeter square. This is the area of our sector, okay, which is formed by the arc AB. Now we have to find the area of this triangle AOB. Okay, so area of triangle AOB is half into base into height. So base is AB and height is OD. Okay, height is OD, base is AB. So first we have to find AB, then we have to find OD. So look here, I draw a line which joins the chord AB and center. OD line I draw, which is perpendicular to the chord AB and also bisect the chord AB. Okay, so look here, I have two triangles, first this one and this one. So this is a right angle triangle, this is also right angle triangle, because this is perpendicular. Now in this right angle triangle, this is 90 degree, so 12 is hypotenuse. Okay, now this is 120 degree and this OD line bisect this angle AOB. These two triangles are congruent. Okay, these two triangles are congruent. Then this angle is equal to this angle, which means this OD line bisect the angle AOB. So now in triangle AOD, this is a right angle triangle. So in right angle triangle AOD, we use angle sum property first to find this angle. Okay, we use angle sum property to find this angle OAB. By ASM, that is angle sum property, angle AOD plus angle ODA plus angle OAD is equals to 360 degree. Now angle AOD is 90 degree, ODA AOD is 60 degree. Why? Because the whole angle is 120. Now this OD bisects this angle AOB, so this is 60 degree. Now this is 90 degree. So angle OAD is what? Angle OAD is what? 360 minus AOD is AOD 60 degree plus ODA is 90 degree. So this is 360 minus 60 plus 90 is 150. Now angle OAD is 30 degree. So this angle is 30 degree, this angle is 60 degree, and this angle is 90 degree. Now look here, in this triangle ODA, this 12 centimeter OA is hypotenuse. Okay, and we have this angle 30 degree. So we take sine. Okay, we take sine theta. We use trigonometry, and sine theta is P upon H. So by using sine theta, we find OD, and OD is the height for this triangle AOB. Okay, so in this triangle, now we use sine theta. So sine 30 degree, we use this as theta. So 30 is what? P upon H. So P is OD for this sine 30, P is OD. So OD upon hypotenuse is what? OA. Why? Because this side is opposite to 90 degree. So this is OA. Now sin 30 is 1 upon 2 is equal to OD is what? We have to find OD, and OA is given, that is 12. So from here OD is what? 12 upon 2, which is OD is 6. So from here OD is 6 centimeter. Okay, OD is 6 centimeter. Okay, first write OD is 6 centimeter. Now I have to find AB. Now for AB, first I find AD. Then AD plus DB is AB. Now look, OD is 90 degree and OD is the perpendicular bisector of AB. So AD is equal to DB. So when I find AD, then AD plus DB is AB. Okay, and DB is equal to AD. So first find AD. So for AD again I use trigonometry and use cos theta. So cos 30 is what? B upon H. Now for this angle, perpendicular is this one. So base is AD upon hypotenuse is OA. So cos 30 is root 3 upon 2 is equals to AD upon OA is 12. So now from here AD is what? 12 root 3 upon 2. Now this is cancelled by 6 times. So from here I have AD is 6 root 3 centimeter. Okay, now I have AD. Okay, so AD is equal to BD and AD plus BD is AB. So again I find AB now. So now AB is what? AD plus DB. So AD is equals to DB. So in place of DB I write AD. Now 6 root 3 plus 6 root 3, which is equals to 12 root 3 centimeter. Now this is AB. Now I have base AB for this triangle and I have height OD for this triangle. So OD is 6 centimeter and base is 12 root 3 centimeter. Now I find the area of this triangle, which is half into base into height. So now look here, area for this triangle, area of triangle AOB is half into B into H. So this is equals to half into base is what? 12 root 3 into H is what? H is OD, which is 6. Which is 6. Now this is cancelled by 6 times. So this is 36 into root 3. We have to take 1.73. So 1.73, which is equals to 62.28 centimeter square. This is the area for this triangle AOB. Okay, now I have to find the area of segment. Now I have area of sector, which is 150.72 centimeter square, and area of segment, which is 62.28 centimeter square. Now I subtract this area from this, then I get the area of segment. Okay, so I write it here. This way, write it here. Area of segment is what? Area of sector. This one 150.72 minus area of triangle, which is 62.28 centimeter square. 63.28. Now after subtracting, this will become 12 minus 8 is 4. Now this is 6 minus 2 is 4 point. This is 9 minus 3 is 6. 14 minus 6 is 8. This is the answer. Area of segment is 86.44 centimeter square. Understood? Let's see one more time. Question said that there is a circle in which radius is 12 centimeter and a chord AB which subtends an angle of 120 degree at center. Then we have to find the area of corresponding segment. Okay. So first I make this figure, clear figure. This is 120 degree. Now this is radius OA 12 centimeter and chord AB is given. No, chord AB is not given. Angle is given, which is 120 degree. Now we have to find the area of segment. So first I get what is given. Then for area of segment, first we have to find the area of sector. So by using formula theta upon 360 degree into pi r square, I find the area, which is 150.72 centimeter square. Now then for segment, again I have to find the area of triangle AOB. So now in this triangle, area is half into base into height. So for this triangle, base is AB and height is OD. Okay, so I don't have the length of AB and also I don't have the length of OD. So first I have to find the length of OD, then length of AB, then I find the area of triangle AOB. So for this, now look here, this OD is the perpendicular bisector of AB. Recall the theorem of class 9. Line joining the chord and center of a circle is the perpendicular bisector to the chord. So this is 90 degree. So now triangle ADO or triangle ODA is a right angle triangle. This triangle is a right angle triangle. So I consider this triangle. Okay, so in right angle triangle AOD, by angle sum property I find angle OAD, this angle. By angle sum property I find this angle is 30 degree. This is 90. This is whole angle is 120 degree. Now this OD bisects this angle. So this angle becomes 60 degree. Okay, so angle sum property I find this angle is 30 degree. Now I use trigo. So sin 30, which is P by H, then by sin 30 I get OD which is 6 centimeter. Now by using cos theta I find AD, which is 6 root 3 centimeter. Now AB is equal to what? AD plus BD. If I add AD and BD, then I get AB. Now DB is equal to AD. Why? Because the line which joins center and chord is perpendicular bisector of the chord. So in place of DB, I write AD. Now AB is 12 root 3 centimeter square. Now I have AB and I have OD, base and height both. So area of triangle AOB is half into base into H. Now I put the values, then I get the result, which is area 62.28 centimeter square. Now area of sector is this, area of triangle is this. So area of segment is area of triangle minus area of sector. So look here, area of segment is area of sector 150.72 centimeter square minus 62.28 centimeter square. Now this is 62.28. Then after subtracting, this is 88.44 centimeter square. Okay. Now let's move towards our next question. The question is, a horse is tied to a peg at one corner of a square-shaped grass field of size 15 cm by a means of 5-meter long rope. Find the area of that part of the field in which horse can graze. So now look here, there is a field in shape of a square. There is a grass field in shape of a square. Both side is given 15 meter. So side of this field is given 15 meter, and a horse in this field is tied at one corner. Okay, by a 5-meter long rope. Then we have to find the area of the horse which is grazed. So look here, suppose this is my horse and this is tied with a rope, and the length of this rope is given 5 meter. Okay, so look here, if I stretch this rope fully, if I stretch this rope, now this length is given 5 meter. Okay, so we have to find the area in which the horse can graze. So look here, if the horse is grazed, then this make a circular path. Okay, look at this. This is a arc of a circle. Horse can graze in a circular path. Okay, if I continue this, then this will become a circle. Now look here, this will become circle, and this angle is 90 degree. So this is a one quadrant of a circle in which theta is 90 degree and radius is given 5 meter. So this is an sector. So we have to find the area of this sector, and this is the part of this field in which horse can graze. So we have to find the area of a sector. Okay, in which radius is given 5 and theta is given 90 degrees. So we have radius which is 5 meter and we have a theta which is 90 degree. So area is what? We have to find the area of sector, which is theta upon 360 degree into pi r square. So theta is 90 upon 360 into pi is 22 by 7 and r square, which is 5 into 5. 5 into 5. Now 94 to 36. So this will become 25 into 22 upon 7 upon 4. Okay, so I use 22 by 7 as 3.14. So this is 25 into 3.14 upon 4. Okay, now this 25 is cancelled out by 4 in 6.25 times. Now this is 6.25 into 3.14. We get 19.625 meter square. Okay, now this is the area of this sector, 19.652 meter square. Now this is the area of horse which it grazed. So So area of field horse can graze is equals to 19.625 meter square. This is our answer. Okay, let's see one more time. Question said that there is a grass field in shape of a square in which a horse is tied at one corner with a 5 meter long rope. Then we have to find the area of field in which horse can graze. So look here, this is 5 meter long rope when horse can graze, and this makes a circular path. Now this is the one quadrant of a circle. This is the area in which horse can graze. Now this is the quadrant of a circle in which theta is 90 degree and radius is 5 meters. So we have to ultimately we have to find the area of a sector. So area of sector is this one, theta 160 degree into pi r square. Now after putting the values, I get result which is 19.625 meter square. Now this is the area of field horse can graze, which is 19.625 meter square. Okay. Now let's move towards our next question. So question is what? An umbrella has 8 ribs which are equally spaced. Assuming umbrella to be a flat circle of radius 45 centimeter, and find the area between two consecutive ribs. Look here, there's an umbrella. Ribs means this upper part of umbrella. Okay, this upper part of umbrella. Now question said that assume this umbrella as a circular, as a flat circle of radius 45 centimeter. So I assume this upper part of umbrella as a flat circle, okay, of radius 45 centimeter, and total there are 8 ribs. So this is ribs. This one is the ribs. Okay. So these are total 8 in number. So 1, 2, 3, 4, 5, 6, 7, 8, and the radius is 45 centimeter. So the length of this is 45 centimeter. 45 centimeter, all are of 45. So we have to find the area between two consecutive ribs. Between two consecutive ribs means we have to find the area of any one ribs, either 1, 2, 3, 4, 5, 6, 7, 8, or any one. We have to find the area of any one ribs. So look here. Suppose I take ribs 5. So look, this is a circle. This is an arc. One part of the circle arc. Now this is a sector made by this arc. So we have to find the area of an arc. So for area of arc, we have to require two things: radius and theta, angle. So radius is given 45 centimeter, but angle is not given. So first we have to find the angle. Okay. So let's assume this is theta. Okay. So first we find theta. So look here, in circle total 360 degree angle, and there are total 8 ribs. So suppose this is my theta 1, then this is theta 2, then this is theta 3, then this is theta 4, theta 5, theta 6, theta 7, and this one is theta 8. So there are total 8 angles. So sum of all theta 1, 2, 3, 4, 5, 6, 7, 8 is equal to 360 degree. So for 360 degree, there are total 8 ribs. So for one ribs, angle is 360 degree upon 8. Now this is cancelled by 8. 8 4s are 32. Now we have there 4, and 4 as 0 is 8 5s are 40. So we have 45 degree. So now we have theta is 45 degree and radius is given, which is 45 centimeter. Okay. Now we have to find the area. So area of sector is what? Sector, and this is rib. Theta upon 360 degree into pi r square. Now theta is 45 upon 360 degree into pi, 22 by 7 into r square. This is 45 into 45. Now this is cancelled. 9 5 is 45. 9 4 is 36. Now 9 5 is 45. 9 4 is 36. Now 5 8 is 40. So look here. This is cancel. 11 2 is 22 and 4 2 is 8. Now we have 11 into 45 into 45. So this is 11 into 45 into 45 upon 4 into 7. 4 into 7. Now after multiplying this, 2 to 2, 7 5 upon 28 centimeter square. Now this is the area of one rib, which is 22275 upon 28 centimeter square. So look one more time. Question said there is an umbrella which has total 8 ribs. Okay, ribs means this upper part of umbrella, and total 8 ribs. Then we have to find the area of one rib, and the radius is given 45 centimeter. So this is total 8 ribs of umbrella. Radius is given 45 centimeter. So first we have to find the angle. So look here, there are total 8 ribs. So for 8 ribs there is 360-degree angle. So for one rib, what is the angle? 360 upon 8, and after calculation I get 45 degrees. So angle is 45, radius is also 45. Then we have to find the area of ribs. Now look here, this ribs is in the form of a sector. So we have to find the area of sector, which is theta upon 360 degree into pi r square. Now I put the values, then after calculation I get area of one rib is 22275 upon 28 centimeter square. Okay. Now let's move towards our next question. The question is what? Find the area of a shaded region where a circular arc of radius 6 cm has been drawn with vertex O of an equilateral triangle OAB of side 12 cm as a center. So look here, there is a figure. In this figure, this triangle is an equilateral triangle which side is given 12 cm. And now by taking O as a center, there is a circular arc drawn which has a radius 6 centimeter. Then we have to find the area of this figure, area of this shaded region, this one, and area of this one. Okay, so look here. First I have equilateral triangle, then I find the area of this triangle, equilateral triangle, that is root 3 by 4 a square. Now second, then we have to find the area of this arc. Now look here, this arc is a major arc. Why? Look, if I complete this arc, this circle, then this will look like this. So now look here, this one is minor arc and this one is major arc. So for this area of shaded region, we have to find first area of this equilateral triangle, then we have to find the area of major arc. And now area of major arc is equal to what? Area of circle minus area of minor arc. So we have to first find area of minor arc and area of circle also. Okay. So first I find the area of this triangle. So first we write what is given. So radius is given, which is 6 centimeter, and side of equilateral triangle is given, which is 12 centimeter. Now first find area of this triangle. So area of triangle AOB is what? This is an equilateral triangle. So area of equilateral triangle is root 3 upon 4 a square, which is equals to root 3 upon 4. Now a square, which is 12 into 12. So 12 into 12. So now 4 3s is 12. So 12 here 36. So this will become 36 root 3 centimeter square. This is the area of this equilateral triangle. Now we have to find the area of this major arc. So for major arc, we have to find area of minor arc and area of full circle. So I added here, area of major arc is equal to what? Area of circle minus area of minor arc. Now area of circle is pi r square minus area of minor arc is theta upon 360 degree into pi r square. Now from this we take pi r square as common, then we left 1 minus theta upon 360 degree. Okay, so look, what is theta here? This is an equilateral triangle, this is O is the center, and this is our complete circle. So in equilateral triangle, all angle is 60 degree. So this is 60 degree and this is theta. So theta is here 60 degree. So now I do it. Now pi is 22 upon 7 into r square radius. Radius is 6 centimeter. So this is 6 into 6. Now 1 minus theta upon 360 degree. Theta is 60 upon 360. So this is cancel out. 6 6 36. 6 times. So this will become 22 into 6 is 12. 6 to the 12, 6 to 12, 113. 132 multiplied with 6 upon 7. Now here is 1 minus 1 upon 6. So now 132 into 6 is what? 6 to the 12, 6 3 is the 18, 1, 19, and 6 1, 7. 792 upon 7 into. So now look, we take LCM. For this, we take LCM. So LCM is 6. So 6 minus 1 is equals to 5 upon 6. So after subtracting 1.6, 1 upon 6 from 1 is 5 upon 6. Now this can be cancelled by 6 or not? Look, this is cancelled by 2, 3 is 6. This is again by 2, 2 3 is 6, 1 or 9, 2 9 is 18, 1 and 2, 2 6 is 12. Now this is cancelled by 6, 3 or not? So 3 1 is 3, 3 3 is 9, 3 2 is 6. So this will become 132 multiplied with 5 upon 7. So this is equals to 5 2 is 10, 5 2 is 15 or 1, 16, and 5 1 6, 660 upon 7 centimeter square. This is the area of major arc. This is area of major arc. Okay. Now, but we don't have to find the area of major arc. We have to find the area of shaded region. Okay. So area of shaded region is area of triangle plus area of major arc. So I solve it here. Area of shaded region is what? Area of triangle AOB plus area of major arc, area of major arc. Okay, so area of triangle is 36 root 3. So I solve it here, equals to 36 root 3 plus area of major arc is 660 upon 7, which is 660 upon 7. This is the area of shaded region. 36 root 3 plus 660 upon 7 centimeter square. Understood? Let's see one more time. Question is what? There is a figure. In this figure, triangle AOB is an equilateral triangle, and the side of this triangle is given this 12 centimeter. And by taking this vertex O as a center, there is an arc is drawn with radius 6 centimeter. Then we have to find the area of this figure or area of the shaded region. So look here, how I find area? There is a one triangle and there is one major arc. So first I find the area of this equilateral triangle. Then again I find the area of major arc. Then I add these two areas. Then I got the answer, area of shaded region. So look here, first I find area of triangle AOB, which is root 3 by 4 a square. Then after putting values, I get result 36 root 3 centimeter square. Now area of major arc. Why this is major arc? Look, this one is minor arc. So this one is major arc. So area of major arc is area of circle minus area of minor arc. Formula is pi r square minus theta upon 360 degree into pi r square. From here pi r square is common, then we left 1 minus theta upon 360 degree. Now theta, what is theta? So this is an equilateral triangle, and all angles of equilateral triangle is 60 degree. So here theta is 60 degree. Now after putting the values, I get result which is area of major arc 660 upon 7 centimeter square. Now I get the both areas, triangle and arc. Now I add these two areas, then I get result which is 36 root 3 plus 660 upon 7 centimeter square. Understood? Now let's move towards our next question. The question is what? The figure describes a racing track goes left and right inside semicircular. The distance between the two inner parallel line is 60 meter and they are each 106 meter long. So if the track is 10 meter wide, then find first the distance around the track along its inner edge and second the area of track. So look here, this is a racing track. Okay, a question said that we have to find the length of this inner side. Okay, this length of this boundary, and second we have to find the area of track, and given is what? The distance between these two parallel lines. Distance between these two parallel lines is given 60 meter, and the length of this track is given 106 meter. Okay, they are 106 meter long, and distance between two parallel lines is 60 meter, and the width of track is also given, which is 10 meter. So look here, this distance is given, which is 60 meter. The length of this track is given, that is 106 meter, and this thickness or this width of this track is given 10 meter. Then we have to find the length of inner side of track, then area of the track. So first we write what is given. So we have given length which is 106 meter. Second thing is given width of track. So I write for W is given 10 meters. Now the distance between these two parallel lines is given 60. So look here. Question said that the racing track was left and right in such semicircular. So this is a semicircular in. This one is also semicircular in. So look, this inner semicircular. This is the diameter for this inner semicircle, and this is the diameter for this inner semicircle. Now the length of this diameter is given 60 meter. So this diameter is 60 meter. Then radius is what? Radius is 30 meter. So now I represent the radius of a smaller inner semicircle by small r. So small r is 30 meter. Now I represent the radius of bigger outer semicircle by capital R. So now look here. What is the radius of outer semicircle? The radius of this semicircle is, this radius is 30 meter. Then this radius is what? This radius. Okay. Suppose I write OA. This is 30 meter. Then OB is what? 40 meter. How? This is 30 and this is 10. This is 30. OA and AB is 10. The thickness of this track is given 10. So finally OB, which is radius of larger semicircle or outer semicircle, is 30 plus 10, which is 40. So R is here 40 meter. Now what you have to find? First, distance of inner side. So distance of this one, inner side. So look here. Distance of inner side means distance of this, which is given 106 meter. Distance of this one, which is given 106 meter. Now the distance of this semicircle, then distance of this semicircle. Now length means, or distance means what? We have to find the circumference. This is 106, this is 106. Now the length of this semicircle means we have to find the circumference of semicircle. Okay, this length means we have to find the circumference. We don't include this diameter in this circumference. We don't only include this one. So circumference of circle is 2 pi r. So circumference of semicircle is 2 pi r upon 2. Why 2? Because semicircle is the half part of full circle. So 2 cancel. So circumference is pi r. Okay. So we find the length from inner side. So length of inner side. Okay. Is equals to what? 2 into this length. 2 into this length, that is 106 meter. Why 2? Because this one is 1 and this one is 1. So 2 into 106. Now plus, we have two semicircles. First one is this end and second one is this end. So 2 into pi r. So now calculate this one. So 6 2 is 12 and 2 1 is 2 plus 2 into pi is 22 upon 7 into r. R is given for smaller. This is 30 meter. So I write it 30. Now calculate this one. This is 212 plus 22 into 2 is 44 into 30. Or we write, so 4 3 is 12, 4 is 12 and 13, 1320. So this is 1320 upon 7. Now we take LCM as 7. So LCM is 7 here. Now 7 into 212 is 7 to the 14. 7 when 7 or 8 and 7 to the 14 plus 1320. Okay. Now add this one. So what I get? 4 or 0 is 4, 8 or 2 is 10, and 4 or 3 is 7 or 1 8 and 1 1 2, 2804 upon 7. Okay. This is the length from inner side. Now we cancel it. Then 7 4 is 28. Now 0, so 0 and 4. So point 40. 7 4 is 28. Sorry, 40. Then 7 5 is 35. Then 5 and 0. 7 7 is 49. So something like 40.57 meter. This is the length from inner side of this track. Now the second one we have to find is area of track. Okay, so I erase this first one. Now look at how we find area of track. This is second one. Area of track here, look. This one is rectangle. So if we find the area of this rectangle, which is L into B. Now this is semicircle. So area of semicircle is pi r square upon 2. Now we have two rectangle. First one is here and second one is here. So again this is L into B and this is pi r square upon 2. So area of this track is, we have two rectangles, so 2 into L into B, and we have two semicircle, which is 2 into pi r square upon 2. So area of track is, we have two rectangles, so I write this is the area of one rectangle into 2, area of two rectangle plus area of semicircle, pi r square upon 2. Now we have two semicircles, so I multiply with 2. Okay, this 2 is cancelled. Now put the values. This is 2 L into B. Length is 106 meter given and width is also given. This is 10 meter. So 106 multiplied with 10 plus, now pi is 22 upon 7 into r square. Radius. So look here how we find radius. There is two semicircle. First one is outer one and second one is inner one. So we have to find the area of this one, this part. Okay. So area of this part is area of outer semicircle minus area of inner semicircle. So in place of r, area of this part is area of outer semicircle minus area of inner semicircle. So from here what we write? This one. So this is the area of this region and we have these two regions. So in place of r we write r square minus r square. Okay. Now multiply this one. This will become 2 into 1060 plus 22 upon 7. Now capital R is 40. So square of 40 is 1600. Now small r is 30. So square of 30 is 900. Okay. Now multiply this one. 0, 6 2 are 12, 2 and 2. 2120 plus 22 upon 7 multiply with, now subtract 1600 minus 900. This is 700. Okay. Now this is cancelled out by 100. So from here we have 2120 plus 2200, which is equals to 0, 2, 3, 4. This is the area of track. 4320 meter square. Okay. Now our chapter area related to circle is over here. If you found this video helpful, then please like, share and subscribe to the Brilliant Academy. Okay. Thank you.